is Mike Leshock, and I cover aerospace and defense at KeyBanc with a focus on space technologies. And we're very excited to have with us today Adam Spice, Chief Financial Officer of Rocket Lab, to kick off the space tech portion of the conference. So, Adam, thank you so much for being here.
Yeah, thanks for having me.
So before we get into the details, I was hoping you could start off with a brief overview of the two segments, launch services and space systems, and then ultimately, what's the long-term vision for Rocket Lab?
Sure. So, a lot of people, understand that Rocket Lab is a launch company, kind of goes with the name. But a lot of people don't realize that 70% of our revenue comes from non-launch related activities, so the space systems side of our business. And so to kind of think about the two portions or two segments, launch again represents about 30%. It's been entirely driven by our Electron launch vehicle, which is the most frequently launched U.S. vehicle behind the Falcon 9. We've had 60 launches. We've got our 61st scheduled for, I believe, the 10th. It'll be the third for the quarter so far. And we have, of course, the most exciting for us going on this year, I think, is bringing our Neutron launch vehicle to market, which is our medium lift launcher to compete directly with the Falcon 9. That can deliver 13-ton to low Earth orbit. It's a reusable launch vehicle, so very much, designed to meet the constellation deployment needs of current operators. The 70% of our revenue that comes from space systems, you can think of it as roughly two equal portions, which the total space systems revenue last year was about $300 million. Half of that came from selling satellite subsystems into the merchant market. So think about things like attitude, direction, and control components, which are things like reaction wheels, star trackers, sun sensors, radio systems, solar panels, software, satellite dispensers, and so forth. And we sell those into other manufacturers of spacecraft, including people like Lockheed, Airbus, Northrop, Raytheon, York, you name it, kind of go down the list of satellite manufacturers. And then the other half of our space systems business is selling platforms. And so we sell two different kinds of platforms. We sell basically satellite buses, which are the satellites independent of what particular payload is on those. So we build buses for people like Globalstar to deploy their constellation needs. We build satellite buses for NASA. We build satellite buses for a range of other customers, including Varda Space that you might have seen. It's an in-space manufacturing startup that's doing on-orbit pharmaceutical development. So we built the bus for that. They developed the actual centrifuge that creates the crystal proteins on orbit. And we re-entered that, I think, 2 days ago, actually back into the Australian desert. So kind of very interesting set of applications. So we sell the satellite buses, and then we also sell full turnkey solutions. Probably the best example of that is we won a large $515 million contract with the DoD to provide their Tranche 2 beta satellites for that deployment. And that's where we do the whole thing. We provide the whole satellite bus, and we also provide the payload, which today we source from third parties, but kind of longer term, consistent with our kind of vision to have full turnkey solutions and end-to-end space capabilities, is to have those payload capabilities as well. So today we stop at the bus. In the future, we're going to add onto those capabilities and add the payload to our quiver.
Yeah, that's great. And I wanted to start with Electron, the fastest launch vehicle to 50 orbital launches ever. And this was done on a budget of only $100 million. So how were you able to be so successful with that launch vehicle on a much smaller budget than most peers and much faster than most peers?
I think a lot of that just comes down to the fact that, Peter Beck, our founder CEO, he's an engineer's engineer, right? So he's involved in everything, and he was key to the development of Electron. And, as he's obviously key to the development of Neutron, which is this larger vehicle. But I think part of it because I think we knew, or Pete knew, that he couldn't compete with SpaceX, for capital, right? So we had to do things very differently. So he took a very different approach to addressing the market. In fact, if you look at SpaceX's history, they started with Falcon 1, which is essentially the same size as an Electron. And then, through a series of misadventures, they kind of moved on from Falcon 1, which never was really put into service, to the Falcon 9. I think it was also a function of the fact that back, if you look at when Falcon 1 was brought to market, this proliferated LEO architecture and small satellite kind of revolution hadn't really gotten a lot of traction, and of course it did about a decade later. So I think he also saw the fact that he didn't want to be kind of drifting around for 10 years without any revenue, any satellites to launch, so he moved to where the market was. So I think we looked at things very, very differently. I think we also have an advantage where about a third of our workforce is located in New Zealand, where the company was started. And a lot of people don't realize the cost effectiveness of doing things in New Zealand. It's just much, much cheaper. You can get 2 or 3 engineers for the cost of one US-based engineer. So it's a very cost-effective place to operate. And we could also scale that in a way because in New Zealand, you're not bound by the same ITAR restrictions as you are in the United States. So we could recruit engineers from Europe, Canada, Australia, lots of other places. And again, taking advantage of the low cost plus access to a pretty broad workforce.
Yeah. And how do you think about profitability for Electron as you did 16 launches in 24, and then you look to the 2025 manifest of over 20 launches? And most importantly, how meaningfully can reusability of the rocket increase margins as you scale? So just how are you thinking about margins as you launch Electron more?
Yeah, so when we started, with Electron, it was a low to negative gross margin proposition that over time got to the point where, last quarter our margins for Electron were in the low 30s. So they've expanded pretty dramatically, and we think there's a path to get to mid 40s, and maybe even push 50 points on the gross margin as we get to a higher cadence. So one thing that a lot of people don't appreciate about the rocket business, it's a very high fixed cost business. So the actual cost to build the rocket from a raw materials and direct labor perspective isn't all that high. Where the majority of the cost for the rocket come into play is basically all the fixed costs of maintaining the factories, the launch pads. It's kind of somewhat of a standing army. So it's all about how many launches you can get off and how you can absorb those fixed costs over a greater number of units. So that's really the path to margin expansion, is going from 16 launches this year to north of 20 launches this year. That kind of gets us towards our sweet spot. And we've said that, look, we get to our target margin model of roughly 45 points of margin, when we can launch twice a month or 24 times a year. So we've got a shot at that, doing that. If all the customers were to show up and we had no breakage between kind of manifest commitments and actual launches, then we'd certainly have an opportunity to do that this year. But I think last year we came into 2024 with 22 launches on the manifest. We launched 16, and we didn't leave any customers' payloads on the launch pad. So basically, that means that we had rockets ready. Customers weren't always ready with their payloads, and so we have to factor in kind of what the breakage is going to be based on their committed manifest. And at some point, we'll get to where we have enough satellites kind of waiting in the wings to be launched that if a customer shifts, we can just pull forward something else. But we're really not there yet. The market's really not that predictable yet. It's still very much an emerging market. Ultimately, again, I think we'll get there, but it probably takes a few more years to get there.
Yeah, go ahead.
No, I guess, sorry, did I get the last part of your question?
You did, and that kind of leads into my next question as well. With the supply-demand environment, Rocket Lab with Electron is the clear leader in small sat, small lift launch. How do you see the launch supply-demand environment over the next few years as you continue to ramp the cadence of Electron? And do you see any competitors coming online that could ramp as fast as you did?
I'll clarify something a little bit. So if you look at the sheer number of small satellites that get launched, we don't launch most of those. So most of the satellites actually get launched on SpaceX transporter missions. So I think you have to differentiate between small satellite, launch versus small dedicated rocket launch.
Right.
So if you look at a transporter mission, of which there's 4 to 6 of those per year, they'll put hundreds of small satellites on one of those platforms, because a Falcon 9 can take 16 ton to orbit. Electron is 300 kilograms to orbit. So we typically take, I'd say our typical mission will have a dedicated small sat that weighs about 200 kgs and needs to go to a very unique orbital location at a very unique time. So they really can't go on one of these generic kind of transporter missions. So you can think about transporter as being like the city bus, and Electron is really more like the Uber, right? It'll take you exactly where you need to go, where you need to go. It's going to cost you more to do that. But people often ask, well, why are people willing to pay a premium? And it's really because they have to pay a premium, because again, the bus isn't going to where they need to go.
Right.
So as far as growth in the market, we've seen pretty consistent growth. I mean, we've benefited from the fact that the number of launches in our backlog continues to increase. The pricing of that backlog continues to increase. And so we see those trends continuing. I think one of the more notable factors right now for the kind of a growth in our backlog and also just the increase in pricing is we're getting increased mix of government missions in there, including like the hypersonics platform that we introduced a couple of years ago. So that's probably the fastest growing piece of our business. And again, given where the U.S. is positioned relative to Russia and China and the need to catch up and really kind of have a capability there that's necessary for national security, we see the demand for that continue to increase, and we're in a unique place to take advantage of that because we bring the cost down dramatically. If you look historically, there might have been less than a handful of hypersonics missions per year. They're very expensive, and they were typically launched on a Northrop Grumman Minotaur or Pegasus vehicle, or typically Minotaur, at a much higher price point, maybe 3 to 5 times the price point that we charge. And they just couldn't make enough of them. It was never built to be a really high volume cadence vehicle. And so we come into the market and we basically tell the government customer, how many of these do you need a year? And we can deliver them. And we'll deliver them at a very attractive price point, which allows, again, the nation to kind of catch up on its needs of hypersonic development. As far as on the commercial side of small dedicated launch, it's a market where lots of people have tried. They've broken their pick, in this market. People like Virgin Orbit that tried and failed, went into bankruptcy, and we bought their primary production facility a couple blocks down the road from us in Long Beach. You've had people like Astra that failed. You have people, ABL kind of failed and now pivoting to missiles and so forth. So, it's actually much more, people think that a small rocket must be easier to do than a big rocket, and it's actually kind of the opposite. What's hard about a big rocket is the scale of the infrastructure and the production, but the technology that goes into both platforms are pretty similar. In fact, in some ways it's harder to build a small rocket that's reliable than to build a big rocket because you typically have more payload margin forgiveness on a big rocket. Because if you take a typical, call it a Falcon 9 or other large launch vehicle, and you look what percentage of its mass throw capability is being used on a launch, it's typically call it half or less. And on a small launcher, you're using a lot of that capacity, almost all of it. So you leave very little fuel margin. I think the average fuel margin for a Rocket Lab launch on Electron is about 3%.
Wow.
So it's pretty tight.
Wow.
And on a Falcon 9, you've got lots of fuel margin, so you can actually have more forgiveness built into your platform.
In shifting gears to Neutron now, your larger launch vehicle with the first launch targeted for the second half of 25. There's a lot of milestones right now that are ongoing that you're working on. What gives you confidence in a launch for Neutron this year?
Well, we originally, when we came public in August of 21, we set a goal of, launching it by the end of 2024. We put a spend target for minimum viable product and minimum viable infrastructure. So we've got a $250 to $300 million budget and roughly 3 to 4 years. And I think, that was informed by our experience with Electron, which has been hugely valuable. As you progress through any rocket development program, you learn things and you kind of have to make adjustments. We changed that schedule initially from end of 24 to middle of 25. And then recently we said, look, there's some items that still need to be worked aggressively, that kind of have fallen out of our kind of target timeline. And so we've kind of given ourselves a little bit more room to get that off in the second half of the year. But we say this every time we get asked the question, like rocket development programs are notoriously fraught with delays because you don't have a bad day until you have a bad day. You can't plan for a bad day. I mean, theoretically, you could say, look, the average rocket development program blows up a tank, and they blow up a test stand for the engines. And so if you did all that, you'd put a deadline out there that was just way far out in time that wouldn't really necessarily track to reality. It's kind of just a guesstimate. And so I don't think you can ever be totally right. I think we're far enough now on the program where we know what the long poles are and we're aggressively working those. And we think we have paths to close those to a launch in the second half of the year. But again, you could blow up an engine next week and take the test stand out with it, and you could be pushed back 3 to 6 months. But fortunately, we've never had that happen on our programs before. We haven't blown anything up on Neutron. We didn't blow anything up on Electron. So hopefully that continues to be the case.
Yeah, and I think the learnings from Electron give you a lot of confidence as well in how you're doing things and expectations for timelines too.
Absolutely.
Now let's talk about the newly announced barge, appropriately called Return on Investment. Could you briefly talk about what that is, and has that always been the plan to land Neutron on a barge in the water versus a traditional splashdown landing?
So we actually have 2 different kind of recovery paths for Neutron. The first one is downrange landing on a barge. And so that looks very much like what SpaceX is doing. They've had over, I think it's probably now close to 300 ocean marine recoveries. So we've learned a lot from what they've done. We've actually got a few of the team members from that team that we've brought on board. So the barge is, as you expect, it's a massive vehicle that gets basically towed out to its location, several hundred kilometers downrange. You land the vehicle on there, and that's where you can use. We estimate 13 ton of capacity in a downrange landing configuration. But we've also talked about doing a return to launch pad, kind of like if you watch what Starship is doing. It's kind of getting caught by the chopsticks, if you will. That's actually, in that configuration, we're estimating around 8 ton. And the reason why you get less mass throw capability is because to basically use the propulsion to bring you back uprange, it consumes a lot of fuel. So it's basically leaves less capacity to put on orbit. But for some missions, if you're only flying 3, 4, 5, 6 tons, then that makes a lot of sense because you save the cost and the time of doing the ocean recovery element of it. That's a longer term plan. I mean, that requires further regulatory work and further R&D, but that's always been kind of in scope from the beginning of the program. Now, our first test launch of Neutron targeted for later this year, I mean, we've designed that to be a soft splashdown in the ocean. So think about the goal, the kind of a measurement of success for that launch will be you successfully get to orbit, you re-enter the rocket, and you basically bring it down, and then instead of laying it on a barge, you basically refire your engines, which is going to be probably the hardest part of the re-entry and landing process, and you basically soft splashdown over the water, and at that point we should be able to tell whether we could have landed it on the barge. But you don't want to land it on the barge, try to land on the barge until you're pretty comfortable that you can do it, because you don't want to damage a $50 million asset, and you also don't want to trigger an FAA anomaly investigation. So the plan is to drop it in the water, pick it up, put it on the barge, bring it back, understand kind of what went well and what didn't go well, and then hopefully we'd have a relatively short path to getting to a successful barge landing in subsequent launches.
Mm-hmm. Great. Well, shifting to space systems, which you had alluded to, it kind of gets overshadowed sometimes by the launch side of the business. And you recently announced Flatellite, a new satellite offering, and that's designed for high volume production for large satellite constellations. Could you talk through the strategy behind releasing that new product? And do you have visibility into potential future constellations where that would work best? Or is it something where it solves the problem of the constellations that are already being deployed today?
Well, the purpose of Flatellite is to, if you ever looked at a Falcon 9 Starlink launch, they've got these, this pancaking of these Starlink satellites, which is a very, very ergonomically efficient way to utilize all the capability of the rocket, because oftentimes the rocket can be volume constrained versus mass constrained, and so you're trying to optimize for mass if you can, right? So it'd be much better to get 25 or 30 satellites on a rocket than obviously 15 just on a cost per satellite basis. So this is really targeted at the bigger volume applications. If you're only having to deploy a half dozen satellites, it probably doesn't make sense necessarily to use that configuration. You'll go to more traditional, hex box kind of design of your satellite. But this is for when you need a lot of capacity. You need to put these large antenna arrays on orbit, right? So if you look at the diameter of the fairing, and you have a pretty capable set of antennas if you can utilize most of that space. So it's really targeted at the comms market, because if you look at Earth observation, those are typically smaller satellites. You don't necessarily need the same size of arrays and so forth. So you could say, and if you think about like Earth observation, some of the form factors there around optoelectronics. So it's basically a big telescope or camera, and that doesn't really, those are kind of limited by the optics, like the actual lenses and stuff. So you want something that just requires a big antenna, which is flat and wide. And so this really does target itself to communications applications. And for those, we see those across government opportunities, commercial opportunities, because if you look at people that are going after, whether it's the direct to mobile market, whether it's going after certain government comms platforms, those all actually are well suited for this Flatellite design.
Do you have an estimate of how many of those could fit on a Neutron?
It really depends. Each one's going to be a little bit different. I mean, Flatellite is really, it's a design, but there'll be the iterations around that depending on the payload requirements and stuff, and how much the platform, power requirements will dictate how much solar you need and so forth. So it's going to vary, but it's certainly going to be a very, very efficient way. And I think, of course, we've also designed Flatellite to work best with Neutron, right? Flatellite certainly will be able to fly on other launch vehicles, but we're not kind of passing up the opportunity to optimize our satellite platform with our launch platform, which really goes to the longer kind of strategic view of creating an end-to-end space company where you can do everything in-house. With the ultimate goal is, yes, you'll first very likely see Flatellite be deployed for third parties, customers, whether commercial or government. But then ultimately, we hope to see these flying, Rocket Lab logos providing our own services to customers.
Absolutely. And that kind of leads into the longer term satellite constellation potential for Rocket Lab. And I know it's pretty clear that the focus right now is on ramping Neutron and Electron and then further vertically integrating space systems. But as you look out 5+ years, and a lot of people consider SpaceX as the closest competitor for Rocket Lab. And I think recently their Starlink revenue surpassed their launch revenue in the past year or two. So how important is it to have a scaled end-to-end space company to be able to build your constellation versus a company spending a large amount of money to a third-party provider for either launch or satellite manufacturing and design?
I think the way to look at that is if you it's not surprising at all, actually, now that the applications part of SpaceX will be bigger than launch, because if you look at the TAMs, launch is about a $10 billion TAM, of which today we play in a relatively small part of that with small dedicated launch. That's measured in, essentially our revenue, because there's not a lot of other players in that space. And they make up the majority of the remainder of the revenue. So launch is, call it $10 billion TAM. The making of satellites and all the subsystems that go into that is about a $30 billion TAM. And then if you look at the applications, it's like a $300 billion TAM. So, I think that, we all see what the brass ring or a prize is at the end of this. It's not launching more rockets to deliver other people's stuff. It's not necessarily focus on making, satellites for other people. It's getting a piece of that $300 billion pie, which hopefully is going to grow pretty dramatically if you look at, some of the third-party estimates of how big the TAM is going to be for applications. So, for us, I would hope that 3 to 5 years from now, again, you're seeing, that we've got our own infrastructure on orbit. We've developed kind of those end customer relationships. I think that, given how long it takes to develop some of those technologies and some of those customers and also acquire spectrum, it's very likely going to be through some forms of partnerships or inorganic kind of growth through acquisition or mergers. I think what we think we bring to the market is right now there is no real competitor to SpaceX in the medium class launch category. It's just not, right? So Neutron, is developed it really is in a position to be the number 2 behind the Falcon 9, but we actually think it's going to be longer term a better vehicle because it's more modern. It's got more composite, construction versus stainless. We brought a lot of things into that vehicle, the fairing designs and so forth, to make it, ultimately, very reusable in a timely and cost-effective way. So when you bring that capability to the market, you're enabling other people to compete where they really can't right now. Like if you're a traditional satellite operator and you're staring down, the barrel of competing with SpaceX, who is now the world's largest satellite manufacturer. They're by far and away the world's most dominant launch provider with the best vehicle that has the lowest cost per launch because of the reusability. I mean, it's very daunting to try to compete with that. So, we're bringing those capabilities to the market, in a way that we don't think any other people can. Because if you look at the hard part of space, satellites are hard. Don't get me wrong, satellites are very difficult to do. Everything in space is hard. But the complexity of launch is so much harder, which is why you see a lot more satellite companies and satellite operators than you see launch companies that are successful. If you look across the history of the launch market, there's been maybe at most 2 handfuls of successfully scaled rocket programs, and most of those are governments, right? Mm-hmm. And so having that's really the moat. That's really what gives you the ability to go in and determine, how you want to play, in certain markets, or even gives you kind of, I'd say, the credibility to go in. And you got to pick your markets carefully. Like if you're going into a market that doesn't require a lot of launch intensity because of its, you only need a few exquisite satellites. Launch isn't that important. Neither is building cost-effective satellites. But if you're going after a market segment that requires global coverage, hundreds or thousands or tens of thousands of satellites, I have to squint really hard to see how you actually do that without owning the vehicle, the launch vehicle. And as I said before, very, very few people in history have been able to pull off the launch piece. So it's much more logical to be able to take your launch position and extend into everybody else's business than for it to go the other way.
Right. No, that's great. And I guess we're coming up on time here, but I had one question before we see if there's any questions in the room. Just on financials and your cash position, about $500 million of cash and marketable securities. How good do you feel about that balance to fully fund Neutron? You've spent $200 million to date on a $250 to $300 million budget. Just what's your confidence in that budget and in your cash position?
I kind of mentioned before, like, the launch business is a bit unpredictable, both when you're actually in production launching, but also developing a vehicle. If you have a bad day on the stand, it could set you back a couple of quarters and cost you lots of money. Like we saw late last year when ULA was bringing their Vulcan vehicle to market, they blew an upper stage Centaur stage up, and you had to rebuild, their test stand and set them back about 6 months or so. So I think in some ways you can never have enough cash to run a rocket company. But I think we don't plan for those kind of days, but we do say, Pete and I always kind of looked at, look, if you get much below $300 million of liquidity, it starts to make us pretty uncomfortable because these are long cycled projects and prospects, and customers tend not to ask us a lot of questions when we have that much liquidity or more. Once you get below that, they start going, okay, well, got a couple bad quarters, then you could be in a tough cash position. Therefore, are you going to be here 4 years from now when the project is supposed to culminate? So we never want to be in that position. And then we've also been relatively acquisitive. We've acquired 4 companies. And we continue to work a pipeline that could consume capital. So I think we kind of watch what the demand signal for the customer is, because there are certain situations where we want to pre-invest scaling capabilities so we don't leave anything on the table as far as launches. And so there's the barge is a great example, right? I mean, that is not part of the $250 to $300 million investment because that's not required for the first minimum viable product, right? It's about putting the asset into a fleet mode and doing recovery. So it's a combination of demand signal combined with how much confidence we have in our deal funnel and some of that coming to fruition. And then also just being practical about, well, you could have a bad day. And if you have a bad day, that's not when you want to be going to the market, right? To make sure that you can continue the development.
Right. Any questions in the room? All right, Adam, thank you so much for being here. Appreciate the time.
Right, thank you.
All right, we're going to continue the space spotlight tonight with another very exciting space company, privately held Vast Space, and very excited to have Sid Harry Herron. Is that correct, Harry Herron?
It's a B+.
Okay, I'll take that. Chief Financial Officer of Vast Space. Sid, thank you so much for being here.
Pleasure.
So maybe if you could start by giving a brief overview of the company for some of those that might not be familiar